Hello and welcome to Amjad Academy. In our reagent series, I will discuss next reagent, that is PCC, Pyridinium Chlorochromate. This is amazing reagent. It is also known as Core-Sagace reagent. The name of scientist Core and Sagace. It is also known as Core-Sagace reagent. And we'll look how it is its structure, how it can look like. So it has pyridinium chlorochromate, pyridinium chlorochromate. So this complex, it is with pyridinium. These are N, it has H, it is positive. It is pyridinium chlorochromate is the structure of PCC. Now we'll go towards its preparation, how it can be prepared. First, we'll look towards its preparation. Preparation of PCC. What will we require? We require chromium trioxide, hydrochloric acid, and pyridine. What it will give us? Just look at here. This nitrogen of pyridine will abstract one proton, and I will show you this chromium trioxide with expanded formula. Let me write here. This is our chromium. It has double bond O, double bond O, double bond O. This chloride ion will attack on this chromium, and one of the chromium oxygen bond will shift towards oxygen. And what we'll get? We'll get this structure. I will write it again here. Chromium double bond O, single bond O negative, single bond, double bond O, single bond. Chlorine, just look. I'm not changing anything. And what else we have? We have this our pyridinium. So this is the preparation of PCC. What chemicals it require? It required pyridine, it required hydrochloric acid, it requires chromium trioxide. So we know how to prepare pyridinium chlorochromate. What chemicals we require? We require chromium trioxide, hydrochloric acid, and pyridine. It will give us pyridinium chlorochromate. Now practically, how we'll prepare it? We'll dissolve this chromium trioxide in hydrochloric acid, and then we'll add pyridine, and a solid material will get. That solid material will be our reagent, that is PCC, pyridinium chlorochromate. Next we'll move toward its action, means its use, its applications. We'll move towards the application of PCC. First, before going towards its applications, we should know why we need this chemical, why we need this reagent. So why we need it? Because in the last video I have given you the topic, that is Collins reagent. The Collins reagent, it has two major drawbacks. First drawback is that it is highly hygroscopic, means it is a moisture sensitive, so we cannot use it. The next is, on adding pyridine On adding pyridine to Collins reagent, it will enhance the rate of reaction. But in the reaction mixture, if pyridine molecule is in a large quantity, it means that the base content it is in a large concentration. So what will it affect? It will affect on the base sensitive functional group of alcohols. So we'll try to avoid it, and the next reagent we'll see is our PCC, Pyridinium Chlorochromate. That's why we need this Pyridinium Chlorochromate. Now the action of this is applications. Application of Pyridinium Chlorochromate. First application is it converts primary alcohol to aldehydes. Primary alcohol to aldehyde. And second application is it converts secondary alcohol to ketones. Secondary alcohol to ketones. And third and foremost important application is it converts tertiary allylic alcohol to ketone, alpha beta unsaturated ketones. Let me write properly. It will convert them to alpha beta unsaturated ketones. Since the beginning, when you have seen John's reagent, it cannot convert tertiary alcohol into ketones. Then Collins reagent, it also cannot convert our tertiary alcohol to ketones. But what is the most valuable application of PCC is it can convert tertiary allylic alcohol to alpha beta unsaturated ketones. So this is the most important application of this PCC, and one question in the NET exam is also being asked on this topic. So we'll move towards its mechanism, how it can convert primary alcohol to aldehyde. Let's see its mechanism. We'll move slightly towards its mechanism. So I will rub these all. We'll shift towards the mechanism of primary alcohol to aldehyde in the presence of PCC. How our Pyridinium Chlorochromate converts primary alcohol to aldehyde. Let's move towards its application. The application is the conversion of primary alcohol to aldehyde using the reagent Pyridinium Chlorochromate. So let's move. Reaction. General reaction. This is our primary alcohol. We'll convert it using PCC. What is the structure of PCC? I will write its different form. What is its different form is, let me write. This is chlorine, this is O negative, and I will write PYH positive. What does it mean? It means that ring of pyridine, and attached to that it is hydrogen, and that nitrogen positive sign I am writing here. So PYH positive means our pyridinium. Okay, now what it will convert? It will convert PCC. Let me write on the arrow PCC. It will convert this primary alcohol to aldehyde. It is aldehyde. Now let's switch toward the mechanism. So look at toward the mechanism. H, H, O, H. I am writing this hydroxyl group like this. Okay, with the two lone pair, our pyridinium chlorochromate structure, chlorine here, O negative, PY, H positive. So, in the first step, step 1, what will happen? This hydroxyl group will act as a nucleophile and it will attack on the chromium. And this chromium oxygen double bond will shift towards oxygen. And what we'll get, I will write after the arrow, R, H, H, single bond O, single bond H, H, then chromium, then double bond O, then this O negative, we have chlorine here, O negative, and our pyridinium molecule. So, what will happen in the next step? Next step I will write above the board because I don't have enough space. Let me write next step. For you have to write down in the notebook below your first step because I don't have a space, that's why I am writing above. So nothing is special in the next step. What will happen in the next step is just a abstraction of this proton. It will abstract this proton as this oxygen is trivalent. It has become positive. To make it neutral, with this oxygen negative will abstract this proton and this oxygen hydrogen electron will shift towards oxygen. Now in the next step, after the arrow, what I have to write? I have to write R, single bond H, single bond H, single bond O, single bond chromium, double bond O, double O, single bond OH, single bond chlorine, single bond O negative, PYH. So this oxygen has become the neutral. This step is called as chromate E star, chromate E star, chromate E star. So what will happen in the next step? So my dear friends, in the next step, this oxygen having this electron, this negative of oxygen will shift towards chromium oxygen double bond, and this chlorine, it is best leaving group in this structure. Now it will get removed with the electron. So in the next step, I have to write minus Cl negative. Now what I'll have? I will have R, single bond C, single bond H, single bond H, single bond O, single bond chromium, double bond O, single bond OH, double bond O. This step is also called as chromate ester because it is forming ester linkage. Okay. Now I will write next step down to the board. Just look at here. Nothing will special happen in the next step. The next step is let me write here. The next step is alpha hydrogen elimination. So this chloride ion, what it will do in the next step, this free chloride ion will abstract this hydrogen, and this carbon hydrogen bond electron will shift towards carbon oxygen double bond, and this chromium oxygen bond electron will shift towards chromium. And what we'll get? We get R, single bond H. This carbon will get doubly bonded with the oxygen, and what remains, what will be the remain will be like chromium double bond, single bond OH, double bond O, and this is our HCl. So what is this? This is aldehyde. This is our aldehyde. So did you got the mechanism? Now the same mechanism will be followed for the secondary alcohol. Let me write for the secondary alcohol. Secondary alcohol. The conversion of secondary alcohol. The conversion of secondary alcohol to ketone with the help of the reagent. Which reagent it is? It is our pyridinium chlorochromate. The next reagent we have, the mechanism of secondary alcohol. Secondary alcohol will get converted into ketones. So let me write, my dear brother and sisters, the next step. The next mechanism is for the next mechanism. The next mechanism is for secondary alcohol. This is our R1, R2 and OH. This is our secondary alcohol. I will react it with PCC. So let me write it in the short so that we'll get the more if space for our mechanism. I will write PCC here, and what we'll get ketone R1 R2 double bond O. So the secondary alcohol getting converted into ketones. So what is the mechanism? We'll shift towards the mechanism. The mechanism will be in the first step nucleophilic attack of hydroxyl group. First step is step 1. R1, R2, this oxygen and this hydrogen. I am writing hydroxyl group so that we can easily make its mechanism. This is our chloride ion. O negative, PYH, that is our pyridinium. So in the first step, what it will do? It will react this oxygen will attack nucleophilically on chromium, and this chromium oxygen bond electron will shift towards oxygen, and what we'll get in the next step, I am writing after the arrow R1, R2. This is our oxygen. It is attached with the chromium. It is oxygen O negative. This is our chloride ion. This is our oxygen negative, which is attached to pyridinium ion. This oxygen is having its hydrogen. So this oxygen is trivalent. It has become unstable. So this negative oxygen will abstract this hydrogen, and this the oxygen hydrogen bond electron will shift towards oxygen to make it neutral. The next step I will write above to this because I don't have space. Let me write what will happen after the arrow. After the arrow, R1, R2. This is our oxygen. We have chromium, double bond O, single bond OH. This is chlorine. This is our O negative with the pyridinium. Okay. In the next step, what will happen? It is our base leaving group. So this oxygen electron will turn towards chromium oxygen double bond, and this chloride as a leaving group will remove from the reaction mixture. This free chloride ion will remain in the mixture, and we'll get after the arrow is R1, R2, O negative, chromium, double bond O, single bond OH, double bond O. It is called chromate ester. Chromate ester. Now we get this first step, and next step is alpha hydrogen elimination. So my dear friends, we'll shift towards alpha hydrogen elimination. The next step is alpha hydrogen elimination. Let me write the mechanism for the next step. The next step mechanism we have is step 2. The step 2 is alpha hydrogen elimination. R1, R2, single bond O negative O, single bond chromium, double bond O, single bond OH. Now in our reaction mixture we have this free chloride ion. What it will do? This free chloride ion will abstract our one hydrogen from this. It will abstract one hydrogen because it has one hydrogen. This alpha hydrogen will get abstract by the chloride ion, and this carbon hydrogen bond electron will shift towards carbon oxygen double bond, and will get R1 R2 double bond O plus chromium double bond O, single bond OH, double bond O plus HCl. What is this? This is our ketone. So we have seen how to convert primary alcohol to aldehyde using PCC, and also we have seen how to convert secondary alcohol to ketones using PCC. So in my next video I will give the mechanism of tertiary allylic alcohol with PCC, and also will discuss the examples related with this PCC. So for the next video, do comment in the comment box. For this session, do like, do subscribe, and help us with your likes and subscribe so that we get motivated and will make more videos. For as far as physics is concerned, please go and watch the series of radiations. It is going on there, and please suggest for the 12th class student to watch the physics and chemistry videos on our channel. So keep watching our supremos lecture. Dr. Amjad Afsar sir is also taking a physics in our academy. So keep watching, keep supporting, do like, do subscribe. Thank you for coming on Amjad Academy.